Now let's talk about continuity. It says a function f of xy is continuous at a point a, b in its domain if the following conditions are satisfied. So the first one is f of ab exists. That means when I plug in the point ab into f, that it has to give me a finite number for my z. And if it doesn't, then it's not continuous at the point ab. And then the next one for number 2 is the limit as xy approaches ab of f of xy exists. That means the limit has to exist. That means it has to go to some finite number, the limit of f of xy as that approaches ab. And the third one is f of xy, the limit of f of xy as xy approaches ab has to equal f of ab. So if any one of these 3 conditions does not hold, that tells me that this is not continuous at that point AB. So let's take a look at our problem here. It says determine whether g of xy of x squared minus y squared over x squared plus y squared is continuous at 0, 0. And right away, if I plug in 0, 0, so I'm looking at this. I'm looking at g of 0, 0. And what I notice about g of 0, 0, I end up getting 0 over 0, and that's undefined. So that means f of ab does not exist. So this implies not continuous. So it's really that easy when I go through this. Now, if that condition held, then I would have to just continue to go through the list. And if all 3 conditions were met, then I would say that f of xy is continuous at the point AB. That's what I would say if that was true. But for this one, it's undefined, therefore not continuous. That's simple. So this definition is the same as when we dealt with it in 2 dimensions. 3 dimensions really doesn't add anything new. It's the same. Remember, the f of x had to exist, or f of a had to exist. The limit of f of x as x approaches a had to exist, and it had to equal the point. The limit had to equal the value of y. And this is just our z value here. So f of xy has to equal z, or f of ab, which is that z value. So anyways, that's it.